We're asked to compare the boiling point of substances based on their understood IMFs. First, let's look at neon, an element, versus HF. We're told they have about the same formula weight. However, neon only has London dispersion forces, the weakest type of intermolecular force in general. And HF has London dispersion forces approximately equal to those of neon, plus it also has hydrogen dipole-dipole forces because we have hydrogen directly bonded to a very electronegative element. And since HF has stronger intermolecular forces, the boiling point of HF is going to be higher than that of the boiling point of Ne. In B, we're looking at neon, argon, krypton, and xenon. These are atomic. They have only LDF forces. And these forces are going to increase with the number of electrons. And as we go from xenon to argon to krypton to xenon, their number of electrons are increasing, and so their boiling points are also going to increase. Okay, and looking at these pairs, which all have similar formula weights within the pairs, neon to HF, HF exhibits hydrogen dipole-dipole forces because hydrogen's directly bonded to a very electronegative element. So the TB is much higher for HF than Ne. For all of these pairs have dipole-dipole forces in addition to London dispersion forces, but no hydrogen dipole-dipole forces. So all of these have higher boiling points of the acid versus the noble gas.